Okay, in this video here we're going to have a look at what we call equivalent fractions. Equivalent is just a slightly bigger word than the word equal, but effectively it means the same thing. So if we talk about equal fractions, um, the reason why maybe we don't use equal is that they don't look identical. They're not identical fractions. They look different, but they represent the same amount. Okay, so that's why we use a slightly different word. What do we mean by equivalent fractions? We'll have a look at these three pictures here at the side. The first one here, we've got a shape which is split up into three sections, which means that as a fraction, we would always write down, if we wanted to shade in a part of that, I would have to make sure that the denominator, the bottom number, is 3. That means that we have split the shape up into 3 equal parts. We have shaded in one blue, therefore the fraction that's shaded blue could be represented by 1 part out of 3, or 1/3. Okay? Now in the second shape, the one underneath it, you'll notice that it's really the same amount of the shape has been shaded. If you compare the size here, they're both the same amount shaded in, except that the second shape has been split up into 6 equal parts. So if we're looking at a fraction of this shape being shaded, I'm going to have 6 in my bottom number here. We call that the denominator. And if I want to say how many are shaded blue, we have to say 2 are shaded blue. 2 out of 6. And if we were to look at the third shape, it's still the same amount of the shape, the same fraction of the shape has been shaded blue, but this time it's been split up into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? 12 pieces means that each piece is 1/12. And we've shaded in 4 of those 12ths, so we can say that that is 4/12. Now, all of these fractions look different, but they all represent the same amount of the shape. In other words, 1/3 represents the same amount as 2/6. Now, what have those two got in common? Well, if you look at what we've just done there, 1/3, 1 and 3, if you double these, if you multiply both the numbers by 2, we get to this numbers in the other fraction, 2 and 6. That's interesting. Is that a pattern? Well, let's have a look at the other one. If we say that 1/3 is also 4/12, well, if you have a look at 4 and 12, aren't they both just 4 times the other numbers? There we go. So if you take any fraction and you multiply both the numbers, the one on top and the one on the bottom, by any number, as long as it's the same number, you will make another fraction that is equivalent or the same as. Okay, let's just check the 2 at the end, because we didn't check them. 2/6 is also the same as 4/12. Does that rule still apply? I think it does, because if you look at 2 and 4, 2 multiplied by 4, sorry, 2 multiplied by 2 gives us 4, and 6 multiplied by 2 gives us 12. So we can be confident that two fractions are equivalent if we can say that there is a common multiplier between the two fractions. Okay, so let's have a look at it kind of in separate little examples here. What I've got here is the fraction 3/4, and what I'm asking you to do is to think, what would that fraction look like if 8 was on the bottom of the fraction? We don't know what goes on top just yet, but we know that it has to be the same as 3/4. So what I can do with my information is to think, what is the multiplier between the pair that I know? Okay, I've got numbers on the bottom in both fractions, and I can see here that 4 multiplied by 2 would give me 8. So therefore, I need to make sure that I do the same operation on the top. 3 multiplied by 2 is 6. So 3/4 is equivalent to the fraction 6/8. If I had 2 pizzas and I split one into 4 and I ate 3 of them, and then I had a second pizza that I split into 8 bits, and I ate 6 bits of that. 1, 2, 3, 4, 5, 6. You notice that I've actually eaten the same amount of pizza in both cases. What about the second one? 2/5 is something over 15. Well, hopefully you could pause that if you want and try it. So what I'll be expecting you to do is to say 5 times something is 15. Well, 5 times 3 is 15. So I need to make sure that the top number is also multiplied by 3. 2 times 3 is 6. So 2/5 is equal to 6/15. Okay, you happy with that? Hopefully. Let's try another pair. So I'll do the first one quickly, and then I'll give you a chance to do the second one. So 5/6 is 20 over something. So this time the unknown's on the bottom, but I still have a pair of numbers on the same level that I can check with. 5 to 20 has to be 5 times 4. So the bottom number that I don't know will be 6 multiplied by the same multiplier. 6 times 4 is 24. 5/6 is equivalent to 20/24. You have a look at the second one, pause it if you want, give you a chance to think about it, and then I'll go over the answer. So we've got 3 to 18 is 3 times 6 is 18. So our unknown in the bottom has got to be also multiplied by 6. 7 times 6 is 42. 3/7 is equivalent to 18 over 42. And one last pair. This is a wee bit trickier because you might not be able to use your mental mathematics. So we can still use written calculations. It's good. We're looking for 3 times something to give us 84. Now you might be able to work that out. If so, that's great. But remember that trying to work out a missing multiplier is the same as kind of dividing. If we think we've got 84 and we want to divide that by the number that we do know we're multiplying by, which is 3. If I do that division, I've got the other number that multiplies with 3. Okay? So we can work back, instead of trying to multiply, we can divide. 84 divided by 3, 8 divides by 3 2 times, remainder 2, and 24 divides by 3 8 times. So in actual fact, our multiplier is times 28. You might not have worked that out in your head, okay? I wouldn't have expected you to in many ways. But what it does mean is that I know that in order to get the missing number, I've got to multiply that by 28. That wasn't very neat. Let's rub that out. And again, I wouldn't expect you to do that in your head, but you've got a way of working it out. 28 multiplied by 8. 8 times 8 is 64. And 8 times 2 is 16, and 16 plus 6 is 22, so the missing number is 224. That's a bit more advanced, and hopefully some of you will be able to see that all we're doing is really having to add a little bit of working out stuff, maybe written calculations. Have a go at this last one then. If you pause it and give you a bit of time, and I'll go over the answer. So we're looking for 5 times something gives us 110, so that we can match that up with 4 times something. 5 divides into 110. We want to find the missing multiplier, so we could go back the way, work backwards from 110 and divide by 5. 5 divides into 1 no times, so 5 divides into 11 2 times, remainder 1. 5 divides into 10 2 times, so 22 is the answer. What does that mean? It means that 5 times 22 is 110. So 4 times 22, you might be able to work that one out because of the way the digits are, is 88. So my answer is 88. Okay, so that's what I'm going to get you to do just now. So I'm going to show you this. You can either just use the screen, you can pause it. I'll take a photograph of it and put that up and show my homework as well. But all I want you to do is for each one, it says copy and complete. You're going to write down the fractions just as I did in my examples. You're going to work out what the missing multiplier, what the multiplier is, and then fill in the missing number. I would like you to see as much as possible these multipliers written down. Okay, I know that some of them you might be able to do in your head, but it's a good habit at the beginning, just to be sure to show you're working as we go along. And if you can do all of them, that would be great. You'll notice at the end of section 2 it gets a wee bit tricky. Some of you might think, oh, I'm not so sure, but I want you to give it a try. You should certainly get section 1 done, and I'd like to see you trying certainly up to about A to F or G before you can really start to think, okay, we'll go, I'm not sure about it. But always try. If you can get someone to help you, that's great. If you have to use a calculator in the last ones, I don't mind either. It's all part of the working out and using resources, so I don't mind using a calculator towards the end if you can work out the answers. Okay, have a go at that, and we'll go over the answers next time in the next lesson.